this video, we're going to start talking about divisor methods. In the previous section, we looked at quota methods. Quota methods use some feature of the state's natural quotas to determine the final allocation of seats. Recall, Hamilton's method looked at the decimals in the natural state quotas, and Lanza's method calculated relative fractional parts from the natural state quotas. With divisor methods, we'll see that they all have some special rounding rule to obtain the initial allocation, and they rely on changing the natural divisor to obtain new modified state quotas that will round to an allocation that works, using whatever special rounding rule the particular method has. The first divisor method we're going to look at is Jefferson's method. Some history about it. It was invented by Thomas Jefferson. It was used in Congress from 1791 to 1842. This was after Hamilton's method had been vetoed. And Jefferson's method tends to favor states with larger populations over states with smaller populations. Now we'll talk about how to allocate seats using Jefferson's method. First, you would follow steps 1 through 4 of Hamilton's method. Remember, steps 1 through 3 are finding the total population, the natural divisor, the natural state quotas. Step 4 says the initial allocation is obtained by rounding all of the state quotas down. Step 2. Since not all seats will have been allocated at this point, modify the natural divisor and use it to find new modified state quotas. If the new modified quotas rounded down, sum to the correct house size, we're done. If not, try a different divisor until you find one that works. And just something to note. In step 2, you're going to have allocated too few seats in the initial allocation. You want to modify your divisor by making it smaller. So for Jefferson's method, you always want to try a new divisor that is smaller than the natural divisor. In general, when modifying divisors, if not enough seats have been allocated, your modified divisor is too big and needs to be smaller. If too many seats have been allocated, your modified divisor is too small and needs to be larger. Let's get to some examples so we can have a better understanding of how this works. So first we'll take a look at this example. Use Jefferson's method to apportion 37 representatives to Maine's 5 counties. So we have our counties, we have our population. The first thing we need to do is find our total population. Then we would use that to find our natural divisor. Keep in mind here our house size is 37 because that's the number of representatives that we're giving out. Now that we found our natural divisor, we're going to use that to find the natural quotas. Remember, we would take each state population, divide it by our natural divisor, and that's how we'll get our state quotas. So these are all of our quotas. Now for our initial allocation, we're going to take each state's natural quota, and we're going to round it down or cut off all the decimals. So we have our initial allocation here. Now we need to add this up to see how many extra seats we need to give out. So our total for our initial allocation is 35, meaning there's 2 seats that we haven't allocated yet. The next thing that we're going to do is modify our natural divisor. So our natural divisor was 2,609.1892. We gave out too few seats because 35 is smaller than 37. So whatever modified divisor we want to try using, it should be smaller than 2,609.1892. So maybe you want to start by trying out 2,000, maybe you want to try out 2,600, maybe you want to try out 2,500. Whatever your first guess is, it should be smaller than the natural divisor whenever you are using Jefferson's method. So let's try 2,500. If we try 2,500 as our new modified divisor, we would take each state population, divide it by the modified divisor, and we have our new modified quotas over here. So again, we've taken each state population, we've divided it by a new modified divisor, and we're going to hope that this works out. So now if we round all of these new modified quotas down, we'll see if it sums up to the correct house size. So we have 10, 3, 11, 1, and 11. And this adds up to 36, meaning we didn't allocate 1 seat yet. So before we didn't allocate 2 seats, now we only haven't allocated 1 seat, so we are getting closer to a divisor that will work. So our divisor here is not small enough yet. We need to try something a little bit smaller than 2,500. So let's say we want to try 2,000 and see if that works. That's smaller. We would then take each state population, divide it by 2,000, and then do the same thing. Round everything down and see if it adds up to the correct house size. So we take each state population, divide it by 2,000, and these are the modified quotas we get. Now if we round everything down, we'll see if this adds up to the correct house size. So we have 12, 4, 14, 1, 14, and this adds up to 45, which is way too large. So this tells us that 2,000 is too small of a divisor and we need to try something bigger. So we'll try something between 2,500 and 2,000. So here our divisor was too small. Over here our divisor was not small enough. So now we'll try another divisor, 2,450. Since it seems like we weren't that far away with our first divisor, 2,500, it makes sense to try something a little bit closer to it. As long as it's bigger than 2,000 and smaller than 2,500, we're on the right track. Now we'll take each state population, divide them all by 2,450, and these are the modified quotas we get now using this divisor. So we will round all of them down, and we want to check that they sum to the correct house size. So 10 plus 3 plus 12 plus 1 plus 11 does add up to 37, which is the correct house size, so this is our final allocation. When you're doing guess and check in general, if you did not give out enough seats, you need to make the divisor smaller. If you gave out too many seats, you need to make the divisor larger. Let's look at another example now. Here we want to apportion 100 seats to the states shown in the table below using Jefferson's method. So I would suggest pausing the video here, try to work through the whole problem on your own, then hit play to see me go through the rest of the solution. The first thing that we need to do here is find our total population by adding up all of the state populations. And we get 4,519. The next thing we want to do is find our natural divisor, and that's equal to total population divided by our house size, which gives us 45.19. So just note our house size is 100 because that's the number of whatever it is that we're giving out. Next, we need to find our natural quotas. So we would take each state population and divide it by the natural divisor. And we will get the following state quotas when we do this. 26.9971, 21.9075, 21.3322, and 29.7632. Now for our initial allocation in Jefferson's method, the rule is to round everything down, the same as Hamilton, the same as Lowndes. So our initial allocation for Himezawa will be 26, for Rakanjima it will be 21, for Kanto it will be 21, and for Johto it will be 29. Now we'll add all of these up to see how many seats haven't been allocated yet. This adds to 97, meaning we still have 3 more seats that need to be allocated. The next thing that we need to do is modify the divisor and find modified quotas. Whatever modified divisor we try, it should be smaller than our natural divisor. So maybe you tried 40, maybe you tried, 41 or something. Whatever modified divisor we try needs to be smaller than the natural divisor. I'll go with 44. As long as you're trying anything that's smaller than the natural divisor, that's a good place to start. Now we would take each state population, divide it by our new modified divisor to get modified quotas. So we've divided each state population by 44, and we've obtained the following modified state quotas. Now we'll round each modified quota down and see if it sums to the correct house size. So we end up here rounding down to 27, round down to 22, down to 21, and down to 30. when we add all of these together, we end up getting 100, which sums to the correct house size, so this will be our final allocation. In this problem, it turns out that 44 is actually the only whole number divisor that works out. If you tried 43, that would have been too small, and your allocation here would have been too large. If you tried 45, which sometimes just cutting off the decimal works, it would not have been small enough.